Who got the bell work? Tyler. What are electromagnetic waves? Waves that can travel through empty space. Does anybody recall what the lowest energy electromagnetic wave is? Jacob? Radio waves. Anybody remember the highest? Connor? Gamma rays. We're going to talk about gamma rays today. Now, yesterday we discussed Newton's laws of motion. Who can tell me the first law of motion? Hey. An object in motion tends to stay in motion, and an object at rest tends to stay at rest until acted upon by what? An outside force. All right? What happens when you have an unbalanced force? Y'all recall balanced and unbalanced forces? Colby?
Unbalanced force. It's not balanced?
When you have balanced forces, does an object move?
Yes.
No. Look, do y'all remember when I had two students up here at the podium and I had them pushing in opposite directions? When they both pushed and the podium did not move, was that balanced or unbalanced forces acting on that podium?
Unbalanced.
They were balanced. You didn't have movement. When you've got an unbalanced, what happened when I told one to push harder than the other?
It moved.
It moved. All right. Unbalanced forces cause a change in motion. All right. Tony, what's the second law of motion?
Acceleration depends on the object's mass and the amount of net force applied to it.
All right. Anybody remember the formula for finding force? Huh? The formula. Connor? No. Lauren? Force equals mass times acceleration, or acceleration equals force divided by mass. All right? Think about this. If I have a bowling ball and a rubber ball in a bowling alley, which one has more mass? The bowling ball. If I roll both of them down the alley at the same speed, which one's going to knock more pins over? Okay? Force directly affects acceleration. All right? If I have my bowling ball and I roll it with more force than a second bowling ball, okay, it's going to knock over more pins. If I roll it slower, what's going to happen?
It's going to
Knock over fewer pins because the acceleration's smaller. Who can tell me Newton's third law? Spencer?
When one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first object.
Okay. We talked about using a bat and a ball, right? You're exerting a force with the bat on the ball. What happens? What happens to the ball when you hit it?
It goes flying.
All right? Opposite reaction. Bumper cars. If Tony's in a bumper car and he's sitting still and Richard hits his bumper car, Tony's bumper car, what happens to Tony's? It moves. All right? Richard stops. What happens when they both hit each other? They bounce back. Action and reaction. All right? For the action that Richard put on Tony's bumper car, Tony also put an equal and opposite reaction on Richard, so they both bounce back. All right? Objects tend to want to move in a straight line. All right? So what happens when you're in a car with your parents and they make a hard left turn or hard right turn? You want to keep going straight, don't you? Same thing with the carousel. All right? That's fair. Now, today we're going to review electromagnetic waves. We talked about those. I'll get you one. I want you to turn to your partner, and I want you to work with your books closed on your sheet. See if y'all can answer those questions. All right? Get with your partner. Look, you've got 5 minutes to answer those questions with your partner. No, you can work with it. Okay, work with Kobe. Work with Brandon.
Oh, yeah.
All right, I want y'all working together. Yeah, no book open. Y'all need to be working on the electromagnetic waves worksheet. You got about 3.5 minutes, okay?
B is for 5.